Okay, last unit of the year, kinematics. We're going to go over this real quickly. There's a whole bunch of videos you should probably watch maybe to figure out how to derive some of these equations, but this is going to just run through all the problems in this particular book. 10.1 says an object travels at 20 meters per second for 300 meters. How many minutes will it take? We're just going to use this constant velocity equation here. And so if we use v equals d over t, we're trying to figure out the time. So that would end up being the time equals d over v. And the d was 300 meters. 300 meters. And the velocity was 20 meters per second. Okay, so if I do 300 divided by 20, I ended up with 15 seconds, but it said how many minutes will it take? Well, 15 seconds is 1/4 of a minute, or 0.25 of a minute. Okay, that's just constant velocity, so that's pretty easy. So then there's three uniform acceleration equations. These are really important to know, and so every problem you get, you basically want to take an inventory and figure out which one of these things you can use. So if you look at this first equation, VF, final velocity, equals the initial velocity plus acceleration times the time. You'll notice that it's important to notice what variable is not in here. So there is not a displacement. So if you don't have any displacement in your problem, you'll probably want to use this equation. This next one is d equals VIT plus 1/2 AT squared. And you'll notice that there is no final velocity in this one. So if you don't have a final velocity in your problem, then I would use this problem here. And in this third one, VF, don't worry about this thing, I'm not sure what that is. VF squared equals VI squared plus 2AD. You'll notice that there is no time in this one. That's why we have three different equations. You'll just use whichever equation you have an inventory for. Now keep in mind, for free falling problems, if you have something that's just falling like off a cliff downwards, then we automatically know what acceleration is. If you don't, then it'll have to be given to you in the problem. But if anything is free falling downwards, then you automatically know, don't forget that you know what the acceleration is. It's negative, because it's down is negative 9.81 meters per second squared. Negative 9.81 meters per second squared. All of these problems we're going to use in MKS or metric stuff, so meters and seconds and things like that. We should do all that and that. Okay, so 10.2, what are the units for velocity? They are meters per second. What are the units for acceleration? They're meters per second, or the way we usually write that is meters per second squared is how we write the units for that. Okay. Speeding up, slowing down, yeah, you can watch the videos on that. Okay, so we're going to do some problems here. Okay, so for this first one, we have a car goes from 30 meters per second to 60 meters per second. So this 30 meters per second, see, I take an inventory of all these things. So what's 30 meters per second? It's an initial velocity. What's 60? It's a final velocity. In 3 seconds, that's time. Okay, what is the acceleration rate? A equals question mark. So you'll notice here that I do not have a displacement in here anywhere. So I'm going to use the very first equation, and I can rearrange a little bit. A equals VF minus VI over T. And I can sub everything in here. I can do 60 minus 30 over 3. And I get a 30 divided by 3, I get a plus 10 meters per second squared is my acceleration rate. What about the next one? Well, I have a final velocity again, got an initial velocity, and I have a time, so I'm going to use the same kind of thing, but this time my final velocity is in negative 20. I'm going to subtract my starting velocity was 80, and I'm going to divide that by 5. That's negative 100 over 5. That's going to be a negative 20 meters per second squared. Okay. 10.6. From rest, all right, that's important. From rest, that means VI equals 0. Okay, so we have that. Vi equals 0. A ball rolls down an incline at a constant acceleration. So there's A. What is the velocity of the ball? That's Vf. Vf equals question mark. Question mark. Ugh. After 8.5 seconds, there's a time. Okay, so the equation I'm going to use here is Vf equals At plus Vi. That's that first equation. I'm going to use that. And so Vf equals, what's the A? It's a -2. What's the time? 8.5. Plus the initial velocity, which was 0, so I don't have to really worry about that. So for A, I get a -17 meters per second. There's the answer for that one. The second question was, how far does it roll in 10 seconds? How far? That's a D. So I need a D equation. I do have a final velocity now, but I'm not going to use, so I could use, there's two different equations I could use. I'm just going to use the first one still. So I'm going to use D equals VI T plus 1/2 AT squared. I'm going to use this one. So what's my initial velocity? It's 0. So this whole first part goes away. So I'd have 1/2 times -2 is my acceleration, times my time is now 10 seconds. I'm change the time. I'm not using this. 10 seconds. It'd be 10 squared. 2's cancel out, and I'd have a -100 meters is how far it goes. Okay. Let's look at 10.7. 10.7. I have a car traveling at 24.4 meters per second. That's an initial velocity. Undergoing acceleration of -8. There's got some weird things again. How long does it take the car to stop? That's time. How long? And stop means Vf equals 0. Okay? So I could use that first equation. I could rearrange it for acceleration. It'd be Vf minus Vi over t. And if I plug in my Vf is 0, right? My initial velocity is 24.4. Divided by the time. Wait a minute. I don't need this. I'm solving for the time. Oh, whoops. Okay. So that was the acceleration. I'll rearrange this. Time equals Vf minus Vi over the A. That's what I need. Okay. So my final velocity is 0 minus my 24.4. I'll divide it by a -8, and I get a time of like about 3 seconds. 3.05 seconds. Okay, is my time for the first one. Now B says, how far does the car move during this time? Okay, so there's a couple equations I could use. I'm not going to actually use the time I just figured out. I'm going to use Vf squared, because we haven't used this one yet. I'm going to use Vf squared equals Vi squared plus 2AD. Okay, how far? I'm solving for D. So that would be Vf squared minus Vi squared all over 2A to solve for my D. Okay, and I have everything I need there. My final velocity squared is 0 minus my 24.4 squared all over 2 times the -8, and that should give me a D of I think it was about 37.2 meters was my D there. All right. Last problem I left is kind of tough. It says a cat with an initial velocity of -13 falls, -13, falls for another 14 seconds. How far did it fall during the last 3 seconds? Okay, so from here all the way down is 14 seconds. Okay, and then I want to see how far does it fall down here, like during 11 seconds, right? So I can figure out how far it fell in this last 3 seconds right here. So I'm going to use the D equation. I'm going to use D equals VIT plus 1/2 AT squared, and I'm actually going to use it twice. I'm going to use it to figure out how far did we fall during 14 seconds, Then I'm going to use it, how far did we fall during 11 seconds, and then I can simply subtract those to figure out how far we fell during the last 3 seconds. So for the first one, the initial velocity is negative 13 times 14 seconds plus 1/2. What's my acceleration rate? Well, it's gravity. It's negative 9.81 times the 14 squared. And then my other one is going to be negative 13 times 11 seconds plus 1/2 times negative 9.81 times 11 squared. And then I'm just going to be able to subtract these to get my overall displacement. And if you do that, by the way, both these are going to be, let's see, I think I might have written them down. This is negative 1143, and this one is a negative 737. So if you subtract these, you're going to have negative 1143 minus a minus, so it's going to be a plus, and you end up with a negative 407 meters. So that means that during the last 3 seconds right here, you fell down, that's what the negative is, you fell down 407 meters. That was a little challenging. You probably won't get something that challenging on the Jedi trial. All right. Last thing we looked at is projectile motion. We're shooting and landing on the same plane. We're going to shoot and land on the same plane. If we don't shoot and land on the same plane, like if you're shooting up into a basket or something, that's way more complicated, and we're not doing that in POE. You will do that in physics. So we're going to shoot and land on the same plane. We have a certain angle here with a certain velocity that we're launching with. And the equation is right here. R is the range, how far over you land. V is the velocity that you're going to launch the pumpkin at, angle. And then we have gravity, which is negative 9.81. Okay, so 10.9 says if the velocity of a pumpkin is 40 meters per second and the angle of trajectory is 30 degrees, how far will it fly? How far will the range over be? So the range is going to equal the negative, okay, v squared to be 40 squared times the sine of 2 times the angle, which was 30 degrees, all over gravity, which is negative 9.81. That's why there's a negative out here in front, by the way, because the negative 9.81, we want those negatives to cancel out, so the negatives won't be there. So you can ignore the negative sign right here if you just put in 9.81 for your gravity. Okay, so 40 squared times the sine of 60 is what that'd be, divided by the 9.81 gives me a 141 meter range that we're going to fly over. Okay, so there's some interesting things about this equation. Because it is a sine curve, there's a sine. I don't know how many of you know much about sine, but that means that the sine of this curve right here, there's actually 2 places that will actually give you the same value. Okay, so there's actually 2 angles that will give you the exact same range. And so the question says, is there more than one angle that will give you the same range? The answer is yes. If so, which means there are, how are the angles related? The angles are related as they're complementary. Complementary. I don't remember if you remember what complementary means. Complementary means that the angles add up to 90 degrees. Okay, so so up in this problem here, I put in a 30-degree angle. Okay, and I got a range of 141 meters. You should go back and do this problem and put in 60 degrees instead. What happens if I put in 60 degrees instead of 30 degrees? You still get 141 meters because 30 plus 60 adds up to 90 degrees. So 30 plus 60 gives you 90, and they're complementary angles. And complementary angles will give you the exact same range. So if I shoot something at 20, that'll give me the same range as if I shoot it at 70. If I shoot it at 30, that'll give me the same range if I shoot it at 60, and so on. So what angle gives me the maximum range? That ends up being 45 degrees. 45 plus 45 is also 90. They're complementary. 45 degrees will give you the maximum total range. Maybe I should kind of show you something here. Let's Let's erase all these strokes here. So what happens here technically is if I shoot like at 30 degrees, I'm going to get a certain range here. Okay, I'm going to get a certain range. That's 30 degrees. Okay, I'm not going to be in the air very long. Okay, I can shoot at 60 degrees, and I'm going to scroll off the screen. I can shoot at 60 degrees right here, and I'm going to be in the air a lot longer time. I'm going to go way higher up in the air, but I'm going to get the exact same range. Okay. Now, what happens if I shot it like I should have done this down here. All right. Let's do this again. Let's do it again down here. So if I do it at 30 degrees, I get a range. There's 30. Okay. If I do it at 60 degrees, I get the same range. That's 60 degrees. Okay. What if I do it at 20? If I do it at 20, I'm not going to get as far. I'm not actually going to get it far. That's at 20. If I shoot at 70 degrees, I'm going to go higher, but I'm still going to go the exact same range I did at the 20. The 20 and the 70 are complementary. They give them the exact same range, but they don't shoot as far as the 30 and the 60 did. The 30 and the 60 came out here. What if I shoot at like 10 and 80? Well, if I do it at 10, I'm going to come right to here. If I shoot at the 80, I'm going to come right to here. See, I don't go as far, but go the same range, 10 and 80. So right in here is a sweet spot where I can shoot at 45 degrees, and I get all the way out to here. And if I shoot at 45 degrees, again, complementary, that would be the same thing. So 45 degrees is the magic angle when you're shooting and landing on the same plane to give you the maximum range. Any other angles, complementary angles, will shoot at the exact same range. So if you're playing golf and you know you need to, that you could shoot at 30 degrees to get it into the hole over here, okay, but there's a tree in the way, it doesn't matter. You can still shoot, you can get in the hole, you can shoot at 60 degrees, go over the tree, and still get into the hole, because that would be the same as what 30 degrees was. Okay, that's kinematics. Hopefully that makes sense.